In this video, let us discuss measures of dispersion. Here we have got the runs scored by batsman A and batsman B. So if you find the average runs scored by batsman A, it is equal to 40 runs. Similarly, if you find the average runs scored by batsman B, it is also is equal to 40 runs. So here what we observed is the mean of both the datas are same, but they differ significantly. So in the first, the runs scored by batsman A varies from 0 to 100, whereas the runs scored by batsman B are clustered around the average 40. Hence, measures of central tendency is not only sufficient to describe the data. So hence, we study measures of dispersion to describe the data set. So measures of dispersion is a measure which gives an idea of how observation spread out or scattered throughout the data. So there are two different types of measures of dispersion. One is absolute dispersion and the another is relative dispersion. In the absolute dispersion, the data are expressed in terms of original units of a series, whereas in the relative measures of dispersion is given as absolute dispersion divided by the average. In the absolute dispersion, we cannot compare if the two data sets are expressed in different units. For example, if the height of the student is expressed in inches and then if the weight is expressed in pounds, we cannot compare in which data set the variability is more. In such cases, we have to go with the relative measures of dispersion. So absolute measures of dispersion include range, quartile deviation, mean deviation and the standard deviation, whereas relative measures of dispersion include coefficient of range, coefficient of quartile deviation, coefficient of mean deviation and the coefficient of variation. So let us discuss now what is a range. So range is the simplest measure of dispersion and it is difference between the largest value and the smallest value in the given data set. So range is the difference between the largest value and the smallest value. So let us see here some example. So here is the data set which includes the point 0, 2, 6, 10 and 12 and the range is the highest value minus the lowest value. So that's the difference between 12 and 0 and then the range is 12. In the second data set, the highest value is 8 and the smallest value is 4. Therefore, the range is 8 minus 4 which is equal to 4. In the third data set, we observe that all the data are 6. There exists no variation in the data. So hence the range is equal to 0. Hence, we observe that in the first data set, the variability is more, whereas in the last data, there exists no variability in the data. So now let us understand what is a quartile deviation. Quartiles are the values which divides the data set into 4 equal parts. Here there are 3 quartiles, Q1, Q2 and Q3. Q1 includes the first 25% of the data, Q2 includes the 50% of the data and Q3 includes 75% of the data. So we know that median divides the data set into 2 equal parts, whereas the quartile divides the data set into 4 equal parts. Let us understand now how to find the quartile deviation. Quartile deviation is given by Q3 minus Q1 divided by 2 and the coefficient of quartile deviation is given by Q3 minus Q1 divided by Q3 plus Q1. So now quartile deviation for individual observations or quartile observation for the ungrouped data. So what is the formula says? First, we need to arrange the data in the ascending or descending order. And then we find Q1 by using the formula size of n plus 1 divided by 4, that particular term gives us the Q1 value. So Q3 is given by 3 times n plus 1 divided by 4. That particular term will give us the Q3 value. Then quartile deviation is Q3 minus Q1 divided by 2. Let us consider an example. So here we have got runs scored by a batsman in a cricket match are listed as follows. We want to find the quartile deviation as well as the coefficient of quartile deviation. The first step is arrange the data in the either ascending order or descending order. So here we have arranged the given data points. Later we shall use the formula Q1 is equal to the size of n plus 1 divided by 4th term. So here what is n? N is the number of terms included in the data set. So here we have got totally 7 data points. Therefore Q1 is 7 plus 1 divided by 4. So Q1 stands at the second term. That means this is our Q1 value. So Q1 is 15. So now let us find Q3. So Q3 is given by 3 times n plus 1 divided by 4. That particular term will give us the Q3 value. So 3 times 7 plus 1 divided by 4. So Q3 stands at the 6th term. So here from here if you count, 6th term is 40. Therefore this is our Q3 value. So now quartile deviation is Q3 minus Q1 divided by 2. So hence we get 12.5 runs. So 12.5 runs is the quartile deviation. So now coefficient of quartile deviation is given by the formula Q3 minus Q1 divided by Q3 plus Q1, and this happens to be 0.4545. So now let us see how to find quartile deviation for discrete observation. So for discrete observation, the quartile deviation is given by the formula Q1 is equal to n plus 1 divided by 4 and Q3 is 3 times n plus 1 divided by 4. So this gives the position. This formula will help us to find the position where the first quartile and the third quartile lies. So here is an example. So here we have got 4 workers whose wages is 10 and we have got 7 workers whose wages is 20 rupees and we have got 15 workers whose wages are 30 rupees. Like that the data follows. So this is a discrete observation. So how to find the quartile deviation? In order to find the quartile deviation, construct a table. So wages is given to us. This is X and then number of workers are given to us. This comes under the frequency value, and now find the cumulative frequency. How do we find cumulative frequency? Keep the first frequency as it is. Now add 7 plus 4. We'll be getting it as 11. Now either add 7 plus 4 plus 15 or add 15 plus 11. We get 26. Then add 26 plus 8, we get 34. So like this, we find the cumulative frequency. After this, we find quartile deviation by using the formula Q1 is equal to n plus 1 divided by 4. So here n is the total frequency. So total frequency is 43. So now 43 plus 1 divided by 4, that happens to be a 11th term. So let us come back to the cumulative frequency and let us identify where is the 11th term. So here 11th comes here and corresponding to that our wages is 20. Therefore, here Q1, the first quartile, is at 20. Now, similarly, let us find Q3 by taking 3 times n plus 1 divided by 4. So, that happens to be a 33rd term. So, 33rd term, our Q3 lies. How to find 33rd term? Again, come back to cumulative frequency. So, here 40 lies after this 34. So, therefore, take the next value, that is 41. Corresponding to 41, our value in the wages is 50. So therefore we Q3 happens to be that at 50. So the 33rd term is 50. So now quartile deviation is Q3 minus Q1 divided by 2. So we get rupees 10 as the quartile deviation. So now let us find quartile deviation for the continuous observation. For the continuous observation, this is the formula to find the quartile deviation. Let us understand this with the help of an example. So here is this problem. A domestic consumption of electricity in a colony gave the following distribution of units consumed. We want to find out the quartile deviation. So this is a continuous data. So in order to find the quartile deviation, so first construct a column. Units is given to us, frequency is given to us. That means so 20 houses consume the electricity below 100 units, whereas 21 houses consume the electricity 100 to 200 units. So like that the data is given to us. Then find out the cumulative frequency as we have discussed previously. So then let us find the Q1 class by applying the formula n divided by 4, that particular term. So Q1 lies at the n divided by 4 particular term. So now here n is total frequency, which is 188. So 188 divided by 4, we get 47th term. So Q1 lies at 47th term. So now how to find that 47th term? Come back to cumulative frequency column. 47 lies after this 41. So therefore 200 to 300. So this class is considered to be our Q1 class. Our Q1 lies in between 200 to 300. So now how do we find that particular value of Q1 is? Using the formula Q1 is equal to L plus N by 4 minus cumulative frequency preceding the Q1 class divided by frequency of the Q1 class multiplied with the class interval. So here lower limit is 200 plus n by 4, already we found it as 47, minus CF, that is the cumulative frequency preceding the Q1 class, which happens to be 41, divided by frequency of the Q1 class, which is 30, multiplied with the class interval, so 100. So hence we get Q1 as equal to 220. So similarly, let us find Q3 class by using the formula 3 times n by 4, that particular term. So similarly we get, if we calculate 3 times 188 divided by 4, we get 141. So our Q3 term lies at the 141 term. Now how do we find 141 term? So again come back to cumulative frequency column. So 141 so lies after the 137. So Q3 class is 500 to 600. So our Q3 value lies in between 500 to 600. So now in order to find Q3 value, we shall use the formula L plus 3 times n by 4 minus CF. CF is the cumulative frequency preceding the Q3 class divided by F. F is the frequency of the Q3 class multiplied with the class interval. So substituting all the values. So here lower limit is 500 and then 3 times n by 4, already we got it as 141, minus cumulative frequency preceding the Q3 class is 137 divided by frequency of the Q3 class is 25 multiplied with 100. We get, upon solving this, we get 516 as the Q3 value. So now quartile deviation is Q3 minus Q1 divided by 2. So substituting this, we get 148 units. So this is the quartile deviation for the continuous data.